Multiple angle identities. These identities are similar to and derived from the sum difference identities. Likewise, they are used to manipulate unfamiliar angles into ones that we know. For example, let's see what sine of 2x is equal to. Sine of 2x can be written as sine of x plus x. Then we use our identity, and we can see that that would equal 2 times sine x times cosine x. Here is the list of double angle identities. You can derive them similarly on your own or commit them to memory. Prove that sine 2x cotangent x equals 2 minus 2 sine x squared. Sine 2x is 2 sine x cosine x, and cotangent x is cosine x over sine x. So the sine x cancels, and then we have 2 cosine squared x. Now, cosine squared x is 1 minus sine squared x, because that's the Pythagorean identity. So if we multiply that out, we get 2 minus 2 sine x squared, and then we see that that is exactly what's on the right side. And there we go. Write cosine 3x in terms of cosine x. First, we rewrite cosine 3x as cosine 2x plus x. So we use our identity, our addition identity, to get this form. Then we deal with the fact that we have a 2 there and a 2 there. So cosine 2x is cosine x squared minus sine x squared times cosine x minus, and then we use the fact that sine of 2x is 2 sine x cosine x, and then we have that sine x left there. When we multiply it all out, we get this, and then we can just go ahead and simplify, and we get to 4 times cosine x to the third minus 3 cosine x. Half-angle identities are used similarly to double-angle identities. They are listed below, but can also be derived. Note, the choice of positive or negative will depend on which quadrant x over 2 is in. Find the exact value of cosine 15. We can write cosine 15 as cosine of 30 over 2. Now we're in the first quadrant here, 15 degrees, so we can use the plus sign. And we have 1 plus cosine 30 over 2. The cosine of 30 degrees is the square root of 3 over 2. And so when you simplify, we get 1/2 times the square root of 2 plus the square root of 3. Find the exact value of tan 22.5. Tan 22.5 equals tan of 45 over 2, which is 1 minus cosine 45 over sine 45. Cosine of 45 degrees is the square root of 2 over 2, and the sine of 45 degrees is also the square root of 2 over 2. And so when we simplify, we get the square root of 2 minus 1. Find cosine of u over 2 if sine of u is negative 3 over 7 and u is in quadrant 3. So we start out with the Pythagorean identity, but why is it negative? It's negative because u is in quadrant 3. So once we solve for what cosine u is, negative square root of 40 over 7, we can then use cosine u over 2 half-angle identity, which is negative square root of 1 plus cosine u over 2. So instead of cosine u, we plug in negative square root of 40 over 7. And then when we simplify, we get negative square root of 7 minus the square root of 40 over 14.